All right, everyone. Well, I think we've waited long enough there. So I'm going to get started. First of all, I'd like to say good morning and thanks everybody for joining and putting up with this last minute change yesterday. I'd really like to apologise for that. Unfortunately, we were only informed about the change to policy yesterday morning, shortly after the staff themselves found out. So while it's disappointing not to be able to do this face-to-face, I recognise that there have been bigger disruptions lately, and so I'm grateful that we still have the ability to do this online. So first of all, I'd like to start by introducing our two speakers. First up this morning, we have Alex Dow. He's a security expert and co-founder of Mirai Security. Over the past decade and a half, Alex has helped organisations prevent and manage cybersecurity threats. He brings over a decade of experience from 3 mission-critical security operations centres, including the Vancouver 2010 Olympics. Outside of this work, he is focused on building and fostering the local cybersecurity community through Mars and B-Sides Vancouver, and that's an event for cybersecurity professionals. But on top of all of this, Alex is also a brand new father who has still found time to join us this morning, so thank you. Following Alex, we have Ray Jung. Ray is an AWS certified IT professional with 20 years experience building and managing complex IT environments. He's worked with Fortune 500 companies as well as small and medium-sized organizations. And he brings this expertise to us here at FuseForward, where he ensures every cloud environment is designed for maximum efficiency and security. So our presentation is split into 2 today. I'll be monitoring questions if you want to ask them in the question and answer screen. And if any are missed throughout the presentation, we'll dedicate some time at the end of the session to answering them. So to begin, we've got a presentation that I'm actually really looking forward to. Alex is presenting his story of cloud enlightenment, and it's called How I Learned to Stop Worrying and Love the Cloud. So I'm just going to flick it over to him.
Well, thank you everyone for attending. And, as Carla said, like the last minute change, a lot of changes are happening and because of the coronavirus. In fact, my annual conference had to postpone. We made that judgment call yesterday, which was a tough call, but we have to slow the spread of the coronavirus. I'm going to present an abridged version of my How I Learned to Stop Worrying and Love the Cloud. And really it's about my journey about being very anti-cloud for quite a long time and becoming enlightened on the opportunities cloud can have, both from a make IT more efficient and better, but my argument is actually more secure. Very quickly about me, Carl, I think did a very good background on me, but really my background is working in security operations centers. I cut my teeth in Ottawa, working in security operations centers in the federal space, then worked out here for the Olympics. So security was a big thing. And really, since I've been out of school, I've been immersed in the high security, high assurance world. And really, cloud wasn't really a good word when you were working in these environments. Nothing that was outside of the walled garden. And over the last few years, I've co-founded Mirai Security. I've taught cloud security for SANS. And this presentation is actually a shortened version of an article I wrote for this year's Cybersecurity Anthology of CISO Perspectives, which is, there are a few physical copies lying around, but it's also a PDF that you can grab. So, first off, coming from Ottawa, even as late as about a project I was working on in 2015 in Ottawa, like any time I tried to say, hey, this is an opportunity if we use this type of cloud service, it was just a bad word. It was just not something you'd bring up. And the reasons for it is that, cloud is different, and cloud is different for many reasons. From a risk management and compliance perspective, first we had this concern, especially after 9/11, about this data sovereignty problem, where the US government had enacted a bunch of laws saying that they can access any data they want, and without necessarily going through due process. So any Canadian or any other country's data was essentially at risk of being accessed and potentially accessed without our knowledge. So that was a big driving force behind, well, we don't really want to put our data on a system that we can't really physically control. And that goes to the next point, is like that no throat to choke. Cloud, naturally, you'll never see where your data is physically. You'll maybe even never know where your data is physically. And that made a lot of traditional practitioners pretty concerned. From a compliance perspective, cloud initially wasn't really great at security. The first time I touched cloud would have been during the Olympics, where the Vancouver 2010 .com portal was actually hosted in AWS. And that was just that front layer. It was just to be able to handle the high volume of traffic and be able to leverage the elasticity of cloud to handle load as well as DDoS attacks. But when we were looking at how this was built out, like, we considered that an outside environment that didn't go near our actual Olympic environment, because just security controls really didn't exist there. And if you're looking at it from a compliance perspective of trying to say, does this cloud environment align to our internal security standards and policies, or external regulatory or compliance requirement, it was very hard to map a one-to-one. And you would really struggle initially trying to convince an auditor that that cloud environment was as secure as your walled garden. The concept of shared responsibility, it is a cloud talk, so we have to talk about this. Risk owners didn't understand what this new paradigm actually meant. We had a lot of people, think that, well, AWS is PCI compliant, so thus I am now fully PCI compliant. And while definitely parts of AWS's service to you is PCI compliant, it is not a turnkey compliance solution. And we were really running into a lot of buyers that thought this was the easy button to get to compliance, was just to go to cloud without necessarily fully understanding the compliance requirements. Now, from a technical perspective, and this is really where my background comes in, is from a security operations angle, is cloud's weird, right? Like, it's an entirely software defined environment, which we weren't really accustomed to back in the mid 2000s, early 2010s. And one of the main things was, like, nothing's physical. You don't actually have an opportunity to ever touch your data or see your data. Now, I do put an asterisk there, because for high security environments where key management is critical, you can actually get a cloud HSM, a key management solution, that is a physical box, and it is your box in the cloud. So that's one of the rare examples of a physical entity within the cloud. But for all intent and purposes, it is software. Next is, it's all defined by code. And a lot of traditional IT professionals didn't really like the idea of having to move to a scripting language and YAML and XML and all these things. It was just not overly native to how their expertise and training had come up. And we still see that with some Windows administrators really pushing back with PowerShell, even though it's here to stay and it is a very powerful tool. Our tools and tactics within a security operations team didn't really work very well with cloud. Our traditional architectures of the walled garden and an edge firewall and putting intrusion detection on had diminishing return on value. In fact, I argue that intrusion detection systems in cloud don't necessarily have a lot of value today, because all traffic is encrypted and you have such granular control over your network traffic that an IDS doesn't really provide much value, at least the traditional network-based ones. Logging, I'm a big fan of logs. I've built out some pretty complex SIM environments. Logs are very different in the cloud. And they don't look the same. How we collect them is much different. And for a traditional SIM or log management environment, trying to get cloud logs in became quite difficult. In fact, the Olympic environment I worked in, there was no syslog streaming. There's no modern day means of grabbing those logs. It was actually an FTP site that would send batch files that we would have to pull. So like for somebody who was always like very interested in real-time logging, this didn't make a lot of sense to me. Lastly, very different visibility. Not all things in cloud are hosts like a computer or a server like we're used to. And a lot of things don't even have IP addresses. Now, when they do have IP addresses or host names, they're ephemeral. They're changing all the time. So when we're investigating logs, how do we track a system that is constantly changing IPs? And lastly, the danger of shared resources, that you are on a shared resource that has a shared CPU and RAM, and thus there is some risk that vulnerability in the hypervisor or your application could actually start seeing that other data. And that is very rare, but there are some proof of concepts where there have been vulnerabilities in hypervisors that have allowed that. And there are some bad things that happen in cloud. And I assure you that Icon is a cloud. So, a few examples of when things go wrong in the cloud, Air Canada, British Airways, and Cathay Pacific last year all had major breaches that involved their web application and mobile application. In fact, altogether, 10 million personal identifiable records were stolen, and because of the EU's privacy legislation, GDPR, $230 million was fined to British Airways for that breach. There was a consulting firm that failed to put MFA on their administrative console, and a hacker got in for 6 months. Marriott, we've all heard of. They also had a pretty massive breach, 500 million, so 500 million people's data was stolen. They were fined 125 million, about half of what British Airways was fined. The reason for that is that they had inherited that breach. They had acquired the software from a third party that already had the breach inside, so they were let off the hook a little bit. Uber, this is an older breach, but it's really relevant because one of them, it was 57 million records. So pretty much if you're from BC, you're not in that database, which is, I guess, a decent thing. They were fined 148 million bucks plus 20 years of privacy audits, that is punitive. That's going to hurt. And that was because of bad development practices, that their developers were using a public Git repository, putting their code up there. A hacker found that they had been putting in code, API keys in their code, hard coding credentials, and the hackers got in, had full access to the cloud environment. I think the other one I'll go with is Capital One. We do know that it was a pretty big breach last year. This was a misconfiguration of a web application firewall, and the hacker had no knowledge of that flaw and was able to circumvent it. But really, those are some obviously major breaches, but I don't think that's a cloud problem. I think that's an us problem. This is not because the cloud is inherently vulnerable. It's because we configured it to be vulnerable. And there's a few reasons for that. First, there's a cultural problem. I think cloud has been designed to work pretty harmoniously. However, development teams, IT, and security operations don't. We're actually sort of like warring factors within the organization. Dev wants to push that code out by Friday. IT is trying to manage performance and availability, and security operations is just putting fingers in the dike, trying to manage the risks that the other two organizations are bringing in, groups are bringing into the organization. And then cloud adoption is typically not done overly strategically. It's typically from one little group within the company that is saying, hey, this is a really cool app, we want to get it going. Or development just wants to get their job done faster. So by circumventing the restrictions IT and security have put on them, they get their job done better. But security is never really considered. And typically this is where we call it shadow cloud, where cloud gets into the organization with no oversight over privacy or security concerns. And doing security isn't overly easy. IT environment's pretty complex. We have been building our IT on top of old IT for the last couple decades. And that means that there's going to be some legacy flaws in there that are really challenging to manage the risk for. There are security standards that exist, but we don't follow them consistently. I sort of joke that when you're compliant today, you're going to be out of compliance by the morning because something within your IT environment has changed. And that's really because there's a lack of process and change management within our IT environments. It's just part of the IT culture. And that creates what we like to call IT drift, that you're drifting away from a compliant state. From a risk management side, we aren't great at quantifying and managing risk. We're pretty reactive in terms of, well, we see our neighbor was breached and we may decide, all right, well, I guess we should probably start looking at security, or we did experience a breach and now we're going to start looking at security. Those are very common knee-jerk reactions to managing risk. And fundamentally, that's because security is really challenging to measure. Like, if nothing happens, did we do a good job? Did we spend too much money? Did we not spend enough money and we don't actually know or have an ability to detect that we have had a breach? Those are major issues in the leadership today, because we can't necessarily have quantifiable data to say, yes, we are doing a good job in security until we're on the news. And, total cost of ownership is boring. When we start looking at like the right way to look at security, I don't think it's always a technical problem. It's a people, process, and technology problem. However, a lot of times we're saying we have a security problem, go and buy some more boxes, buy a firewall, buy antivirus. And we're not realizing that the people and process side is the glue that actually enables those boxes to do great things. So, I was pretty resistant to cloud for a long time. After the Olympics, I decided to stay out here, and, Vancouver is a very different world than Ottawa when it comes to bleeding edge technologies like the cloud. And I just kept on, losing arguments of why cloud was insecure. And I started thinking, I'm going to start figuring this out. What is secure about, what's not secure about? And then it just clicked. First, cloud service providers did start taking security seriously. I think we can all admit that upfront cloud security providers didn't, but that has really changed. First, they've become leaders in compliance and supporting their customers' need for compliance. And they've also published several white papers on how they're managing security. I think much better than how we can articulate how we're doing security in our own environments. And they started creating, it is cloud, so something as a service. So a lot of security as a service type offerings have come out that have allowed us to start taking advantage of externalizing security work. What I love about it, as a kid, I was a Lego maniac, is the Legotization of IT. So they've created all these different components within the cloud that work very well together, almost like Lego. They click in together. Hyper interoperable. And that means that almost everything in the cloud talks to itself and is typically managed through one interface. And they've almost appified almost all functions of IT, meaning that we can really have a consistent rollout of how we're doing IT. It's not just a bunch of spot solutions that half your team understands that technology and half the other team understands the other technology. Also, what I really liked was this benefit of decoupling. So, if your business is running an application, do you really need to be a Linux administrator? Do you really need to be a network administrator? I would argue not. And a lot of organizations try to be all the things and realize that they're really spreading themselves too thin. By leveraging certain cloud technologies, such as platform as a service, you're now able to outsource the responsibility of managing an operating system, configuring it properly, patching it, all things that, generally speaking, we're not that great at. The codification of IT, I think there's some resistance with traditional IT professionals that don't want to get into the world of coding. And I'm by no means a developer, but I definitely understand why scripting is of value. But what really is the benefit here is that standardization, is that we're able to be able to roll IT out consistently. If I need to roll out 3 servers or 1,000 servers, they can look identical. And in traditional IT, I just don't think that is as easy, especially to do that consistently and for the long term. We're able to actually version IT so that we know that version 3 was actually not that good. So we either reverted back to version 2 or we upgraded to version 4, not trying to troubleshoot in real time in the live environment. The concept of queryable infrastructure is really fascinating because when I do this talk, I point to an office tower out the window. I say there's a data center in there, and I challenge that IT manager to figure out how to like audit the entire environment and give me an accurate depiction in the next 4 hours. And I don't think they can do it. Whereas cloud allows you to be able to query your infrastructure and get 100% accuracy within seconds. And lastly, the automation orchestration piece, because now we're able to script and the back end of the cloud is receiving all of those commands, you're able to start doing a lot of automation scripting. So are cloud service providers any good? I would argue the tier ones, the AWSs, the Azures, and maybe even GCP have a major incentive to do security better than us. They are perpetually audited. Here's just an example of some of the standards that they are auditing themselves against, and they built a really complex compliance program. So essentially what that means is that they have built in the ability to always be compliant. That's obviously a fundamental foundation of their organization. But something to take into consideration, and this is back to the shared responsibility model, is that cloud service providers will never own all the risk, and we as risk owners of our data and our customers' data need to acknowledge where that line of delineation happens and what we are ultimately responsible for. So ideally, you don't want to trust. You want to verify that they're doing the right thing. So don't assume they're doing the right thing, especially in the world of SaaS. I've got a great story that I'll save for another time. Really circling around that the SaaS is out there, look good, they have a beautiful web page, but they don't necessarily take security as seriously because they're typically a startup, they're running lean, they're running mean. And that is a big concern if you're starting to put your sensitive data, your regulated data into their environments. So ideally, you want to start reading through the reports on compliance, if they have them, look at their audit reports, security tests, and white papers that they have to really understand, do they get security, and are they going to be supporting your security requirements? And how cloud provides security. So as I was sort of mentioning that back-end infrastructure, I call it homogeneous infrastructure. There's a single management control plane that all cloud assets connect into, and that's all managed over a back-end API that we don't really have direct access to. But that's a really good thing because that actually sort of limits the exposure of your management interfaces of your cloud. I really love the ability to be able to interact with almost every piece of cloud through an API or a CLI command. And we've had identity and access management for obviously decades with Active Directory and Novell, but I think there's been a lot of opportunity to learn on how to do that well. And in AWS's case is that they've really done a good job of understanding how to provision access and permissions to users and even beyond users actually to cloud assets. From a prevention perspective, I love the ability to actually have consistent IT, and maybe I'm just a jaded IT professional, but I've never seen a consistent IT environment that's bare metal. In a cloud, it is almost by default that you can have it if you start embracing some of the cloud practices. Reducing the attack surface. This is going to be a little bit of different architectures, but having the ability to minimize what the attacker could actually interact with your system. And the most basic example is you don't have management interfaces exposed to the internet as an example, but you can start leveraging with some really cool architectures an ability that your front end, where your web application is, and your back end, where all the sensitive data is, doesn't actually have a direct IP connection, but rather over a message bus so that it's a very one-way communication path, really limiting a hacker's ability who compromises the front end to get to the back end data. The star as code, again, is infrastructure as code, but also security as code. Being able to apply security controls in your code and be able to verify them and audit them. Concept of immutable systems. I love this idea. Never troubleshoot a system, never update a system in real time. This is a really great concept that it comes from the dev world and what IT should be embracing. That whenever you need to patch a system, you just deploy a new one with the updated software and then take down the old system rather than patching in real time. From a detective and response perspective, that queryable infrastructure allows you to always have full situational awareness of your environment. Logging actually is pretty decent. I sort of joke that why logging is so good is that that's how they know how much to bill you, but we get the benefit of seeing a ton of activity that's going on in the environment, what users or administrators are doing, what systems are running, etc. Lots of cloud native tools, and as I mentioned, the automation. I'm a big fan of the Center of Internet Security's critical security controls. It's the top 20 for a lot of you. Just looking at the top 6, which is the foundational stuff, these are the controls and how cloud really helps out. So asset management, spelled that wrong, it shouldn't be access management. So both control 1 and 2 is all about hardware and software. So having that queryable infrastructure gives you 100% visibility. There's built-in agents to put it into your operating systems, and then infrastructure as code allows you to really be able to quantify what is in your environment, and at the lowest common denominator, be able to hit Control F and search through your infrastructure as code scripts to see what's in there. But more advanced software allows you to actually enumerate your environment through looking at that code. Continuous vulnerability management. First, native vulnerability scanner within the cloud that will start looking at both how the configuration of your cloud is happening as well as your operating systems. The ability to do automated patching, that's, again, taking the concept of immutable systems, and as soon as a system boots up, it automatically updates itself before it goes online is a great concept. And the whole idea of maybe we don't want to be administrators of operating systems. And I argue that when we do vulnerability assessments at Mirai, we always work with IT teams and they're saying, yeah, we got a pretty good patch management system, but we always find a few systems that just were forgotten about. And those are the systems that attackers are going to find and compromise. Managing administrative privileges, that next generation identity and access management, I think, is a really good piece. You don't have to be an administrator all the time. You can escalate your privileges as required. That granular privilege delegation means that you don't need to be giving everyone full access to all the environment, but you can provide really granular access, assign it to groups and the whatnot. And it's super easy to start auditing who has too much permissions. From a secure configuration perspective, the cloud service providers like AWS provide lots of pre-built secured images. The only caveat with that is that in that marketplace of images, not all things are great. So you want to really stick with the AWS images and then vet some of the other marketplace. I know Azure did a study and 80% of the images on the marketplace were full of vulnerabilities and or malware. So it's something to take into consider. When you're spinning a system up, you can have a startup script, and that startup script can then overlay all the custom hardening that you're doing. I think that's super awesome. And then this idea of do you really need to be managing the operating system? I sort of joke that infrastructure as a service where you're managing the operating system and the virtual machine is sort of that stepping stone for us IT Luddites to get to the cloud. But in actuality, operating systems is going to be for hobbyists. We're not going to really care about the operating system in the future. We're going to have our applications sitting on platform as a service offerings instead of managing the entire stack. And then with logging and monitoring, virtually everything is logged. And the native cloud monitoring is actually pretty solid. I think it probably covers about 80% of what I'd be looking for. And then the rest, you can pump that data out into a SIM. There's lots of interesting ways of getting that data out of the cloud environment and into your on-prem SIM if you still have an on-prem SIM. So to wrap up, I think really cloud is awesome. It is an opportunity of a lifetime. I think it's a greenfield opportunity for most of us IT professionals and risk managers, and it allows us to take advantage of these next generation services that we're just never going to be able to get in our own bare metal data center. but cloud is only as secure as you design and operate it. We've definitely seen what happens when cloud adoption goes wrong in the news. The concept of lifting and shifting, it can increase your risk of tech debt because you're bringing bad from your data center into the cloud. So you really want to be assessing what you're going to actually take from the data center and put into the cloud. So, assessing risk of adoption is going to be crucial for the organization. The organization should see it as not just spot teams grabbing cloud, but having a more broader strategy. Threat modeling will really help understand where those attack surfaces are. Defining and enforcing standards. Defining the standards is very important. Enforcing them is crucial. And I think cloud really enables that much better than a traditional IT environment could. And leveraging automation is going to be key to helping really mature your prevention, detection, and response capabilities. Thank you very much. That was my slides.
Hi, everyone. Thanks for that, Alex. I know that we mentioned that we'd have Q&A at the end, but I just wanted to point out that if you do have questions throughout the presentation, oh, look, one's already popped up. You can ask them in the panel. And I've got a couple that have come in. So Ray, I hope you don't mind if we just take a moment to answer these ones now.
Sure.
Yeah. So the first question I have is, this is for us actually, how does FuseForward provision its managed security services on the top of what is responsibility of the public cloud provider?
Well, why don't we wait until I go through my slides, and then we can talk about that afterwards.
That's definitely coming up in Ray's presentation. And the second question that I had, how should people deal with ransomware threats in the cloud? Alex, I don't know if you have any thoughts on that.
So again, if you were doing a pure lift and shift, where you're taking 10 Windows or Linux servers and moving those into the cloud, then you're essentially just having a second data center. So you still got the same problems. I would actually argue that if you take advantage of the cloud, you can actually eliminate the risk of ransomware, at least the types of threats we're seeing. So first and foremost, a good architecture of your cloud environment to minimize, essentially the blast radius, that if malware and or ransomware gets into your cloud environment, it really is affecting one system and one system only. There's not going to be any lateral movement. And cloud is really good at enabling that type of isolation, unlike your data center where your servers are sitting on, at best a segmented network, but it's still sitting on a layer 2 segment with all the other servers, and the propagation spreads. Secondly, cloud enables this opportunity with the immutable system concept, that you have your backend data store, which could be a managed database, which again will be likely unaffected by most malware. And then your front end, like your processing layer, is actually the immutable Linux server or whatnot. Now, this concept of immutable systems means that, do you need SSH enabled at all if you're never going to log into the server? So if you can reduce that attack surface, I think that you're going to really minimize the attacker's ability to get malware on there. Secondly, when the attacker does get malware on the system, you just kill the system and spin up a new one, right? So it becomes whack-a-mole for the attacker. And ideally, if you can increase the cost of the attacker to keep on recompromising your system until you figure out how to plug the hole, they may be moving on to a different target.
Thanks, Alex.
Yeah, excellent. Thank you. Ray, I'll pass it over to you.
All right, thank you.
Thanks,
Carla. So thanks, Alex. That was a very good presentation. So I'm just going to follow on in regards to enhancing your cloud security. And I just want to cover 2 points, basically your security responsibility as well as securing your cloud. So as Alex alluded to in regards to shared responsibility model, I'm not sure if everyone knows, but this is the shared responsibility model that AWS publishes. And it shows what AWS is responsible for, as well as a customer, what you're responsible for. So when we look at the shared responsibility model, we're actually, for AWS, they're basically responsible for the cloud itself, so the security of the cloud. So basically, if we're looking at the compute, storage, database, and networking, as well as the actual, basically, if we're looking at the infrastructure, for example, the regions, the availability zones, the edge locations. So that's what AWS is responsible for mainly, and everything else above that is basically what you as a customer is responsible for, is what is the security in the cloud. So we'll get into more detail in regards to that, but basically that's the dividing line in regards to the shared responsibility model between you as a customer and AWS. So in regards to cloud misconfiguration, at a glance, there's a 42% increase in cloud misconfigurations, and in the last year, there was over 33 billion records exposed at a cost of approximately $5 trillion in cost. So the cost of misconfiguration is actually greater than the cloud spend. This increase in misconfiguration is actually correlates to the adoption of cloud. So as more people are actually adopting the cloud, we're finding that there are more cloud misconfigurations that are occurring. Also, with the recent uptake of the Internet of Things, or IoT standpoint, from enterprises as well as end users, it seems to be a new threat vector that is basically affecting this cloud misconfiguration as well. So with the advent and the uptake of IoT, that's just a new threat vector that's coming through. So let me play this video for you.
The website claims that information from more than 10 million people who stayed at MGM Resorts properties may be in hackers' hands. Well, according to the website ZDNet, the personal information was posted to an online hacking forum this week. MGM Resorts couldn't confirm the exact numbers. A spokesperson says, though, they discovered unauthorized access to a cloud server that contained information of previous guests. But the company is insisting that no financial, credit card, or password data was compromised, and that all guests involved have been notified. Well,
so what we can take away from that is, even though there's no financial data or passwords that were stolen, the actual leaked individuals are now at a higher risk of spear phishing or other social media attacks, just because of the fact that this information was stolen from MGM. Sorry. Some more examples, and Alex did go through Marriott as well as other examples, but I just like to highlight a few more things here. Booz Allen, they were actually compromised based on an insecure S3 account, and what was stolen from them was actually battlefield imagery and administration credentials. So again, that would be associated with the U.S. military. Another example of an S3 misconfiguration was the Dow Jones. 2.2 million people, their personal identifiable information was exposed and compromised. Time Warner Cable, again, another S3 configuration, but this was basically from a third party, and 4 million customers, personal identifiable information was compromised. I'll just go through one more. Accenture, the master access keys for Accenture's accounts with AWS management system was stored in plain text. It was stored in plain text, and it was stored in an S3 bucket. So I'll next talk about securing your cloud. So as we've seen before, this is the shared responsibility model from AWS. So this is basically what an EC2 or Elastic Compute Cloud shared responsibility model would be. So for example, as a customer, being that you're responsible for everything that's in the cloud, you're responsible for encryption on your client side as well as your server side. You're also responsible for your network traffic protection, i.e. encryption, integrity, and identity. In addition to that, because this is EC2, you have your responsibility for an operating system. You have to patch it, as well as the network and firewall configurations. And then on top of that, you also have responsibility for your platform applications and identity management. And then of course your customer data, which you will always own. So in regards to encryption, on the client side, server side, you need to consider what you're looking for in terms of in transit as well as in rest. So how do you secure the cloud? So security monitoring. So as Alex was saying, it's always a moving target. So basically, if you make a configuration change, essentially you have to reconsider everything that has been done and make sure that all security holes have been plugged, as well as looking at all the vectors that could be affected. And being that it's in the cloud, the speed and agility, you have to consider that as an important aspect. In regards to security monitoring, you need to look at what, as Alex was saying, AWS provides, as well as in regards to successful and not successful logins by end users, as well as privileged users. And that's basically coming down to who's accessing your system, who's coming in, who's going out. And you need to really understand what your traffic flows are. Identity and access management. At FuseForward, we have separate identity management systems. We separate end users from privileged users, such that they have different credentials. So basically, people coming in as an end user, basically, they have different credentials as a privileged user. And if one gets compromised, then both are not compromised at the same time. As well, no shared users, no shared passwords, ensuring password policies are adhered to. And that's just good maintenance in regards to identity and access management. Multi-factor authentication. So this can be applied to privileged users at a minimum, but it can also be deployed for your end users as well. So in the need for additional security, you can implement multi-factor authentication for your end users, but at a minimum, you should have multi-factor authentication for your privileged users. Firewalls. You need to look at the firewalls. Effectively, this is the cloud. It's different than an on-prem. You still need to have some form of firewall. You have to look at and select a firewall that is flexible enough to allow for, if you do consider having on-premise as well as in the cloud as a hybrid environment, you have to choose a firewall such that you can have one pane of glass such that you can manage both your on-prem as well as your cloud environment firewalls. Encryption in rest as well as in flight. So in transit, ensure you're using HTTP as well as the certificates, as well as load balancers within AWS. In terms of encryption at rest, you need to encrypt all your volumes when you're stored within the cloud. As well, you can use your supplied AWS keys, or if you have your own encryption keys, you can bring those encryption keys as well. In regards to encryption keys and certificates, you need to ensure that you also rotate these as well, because things always change and you need to be constantly changing as well. Intrusion prevention and detection. This is important as well. Prevention is primarily the, you want to prevent things before they occur. So prevention is important, as well as the detection of the intrusion. And this goes down to basically the traffic inspection that goes in and out of your VPC or virtual private cloud. Patching of our operating systems. If you're running EC2 and you have operating systems, you need to ensure that you're patching, and this goes without saying, because ultimately, as we are on Tuesday, Windows is always coming out with Patch Tuesday, and I was reading that they came out with 100 patches that are required for today, and I have to reboot my laptop after I do this presentation because of that. Security audits and penetration testing. These should be performed annually at a minimum, and the big takeaway for all of these points is that it's not just a set it and forget it, and it's a continuing updated process, such that, as Alex was alluding to, if a configuration changes, you need to relook at everything and revisit things. And basically, it's not a set it and forget it, and you need to stay on top of your security. So at FuseForward, we have a product called FuseSecure, and it is a managed service that we provide that basically takes the majority of your responsibility as a customer of the security in the cloud, and basically as a managed service, you offload it onto us, and then we will take that responsibility for you. But ultimately, you continue to remain as responsible for your customer data. And this is available as a subscription on a monthly basis. FuseForward and Mirai, we both provide security services, and we are available to partner with you and work with you on any cloud security concerns, whether it's consulting, assessment services, right through configuration and delivery of cloud security technology, as well as to support compliance requirements in the cloud. So I'd like to pass this back to Carla. Carla?
Hello, hi. So that brings us to the end of Ray's presentation. I'll just wait a minute for more questions to come in. But while we're doing that, I just wanted to again thank everyone for coming to a webinar instead of a breakfast briefing. We're looking at what we might be doing in the near future. Obviously, the ability to have events in the next few months is a bit iffy, but at the same time, our plan is to continue these in the future. So if you're not on our invite list, or you know someone that you think should be, I've put the URL there. You can go there, fill in the form, and that will put you on our invite list. So you will get a chance to come to our future events, and hopefully they're in person and healthy, and we're all able to have coffee and breakfast together. Again, if you'd like to reach out to any of us at FuseForward, I've put our contact details here on the left-hand side. sales@fuseforward.com will come to any of us, Ray, Duncan, myself. We're also on LinkedIn and on Twitter. So we'll be sharing content, including options to view this webinar through those channels. So if you follow us there, you'll also receive the latest updates. And on that note, I've got another question that's come through, and I'm not sure Ray or Alex who the best person to answer this is. Do you have tools to learn baseline data flows?
Ray, did you want to answer that one first, or do you want me to?
Tools for baseline data flows. In terms of, that's pretty wide open. We can monitor traffic in and out of any virtual private cloud. So we have tools that can allow for that, but that's quite wide open. Alex, you want to tackle that one?
Yeah, I think Gabriel might be asking all right, so this is what's in my data center now. I need to understand those data flows to then move into the cloud. So I'll answer that scenario first. We could look at it from a NetFlow perspective from your firewall, and NetFlow is probably a pretty good example that firewall logs would be. And while you don't necessarily need to buy a SIM to do that, that is a tool that would help with that. But there's likely a lot of open source solutions that help with understanding what the connectivity is in your environment, so that you can start choosing what to migrate over. And as Ray alluded to, there's a lot of visibility opportunities in the cloud. The only, I think, caveat would be that the traffic, just like in your traditional environment, has to cross essentially a VPC, which would then log that connectivity. Any inter VLAN traffic would probably, you'd either have to use a network tap or be observing it from the host perspective.
Great, I have a thank you to that question. I actually have a question. Alex, you were talking about SaaS providers and evaluating them from a security perspective before you use them earlier in your presentation. I was wondering, what if you have a SaaS provider that you're really wanting to use and they don't meet your data standards? Are there any actions you could take, or is that a no-go?
A little tongue-in-cheek is run. And just to give a little bit more context, at Mirai, we are a modern startup, so we are using SaaS as well. A really interesting stat is 80% of cloud utilization is not AWS and Azure, it's SaaS. And most people say, well, all that SaaS is sitting on AWS, and you're not wrong. It totally is. But you as the consumer of SaaS has a contract with the SaaS provider, not with AWS. So while AWS is doing a lot of great security under the covers, that top layer where the application sits, where your data sits, is managed by the SaaS provider. And those SaaS providers are typically startups. It's a team of 10 developers. So security doesn't get necessarily applied up front. So, our example, we were using a SaaS provider for a business application. It was pretty decent. There were some user interface bugs that we reported. But one day we, and again, not really trying here, but decided to modify the URL a little bit. And all of a sudden we're in somebody else's account. And we were able to discover that they didn't put any authentication mechanisms in place. So once you're an authenticated user, you can actually look at any user's data. So we were looking at every one of their customers' data sets. So we notified them of that. They've said, well, that's not really a concern of ours because it would be really hard for people to guess. And we sort of argued, well, we did it just we were bored one day. They did end up fixing it. However, we decided after 6 months of circling back and hey, so what else are you doing with security? And they said, we're really good with security. We're adding more features. That made me really it just didn't pass the sniff test anymore. And we moved on from that organization. So, back to Carla's question is, looking at cloud is many things to different people. SaaS is going to be typically managed by smaller organizations that may or may not have the staff to do security well, maybe not the foresight. I think that is changing with with so much privacy legislation really pushing that, plus all the consumers like yourselves are saying, no, actually, we really do care about security. Please add that as a feature. But if they can't tell their security story, I think you should be looking for a different provider.
Great. That's good advice. Ray, did you have anything to add to that, or?
Again, this is going back to what Alex was talking about. Yeah. If that application, it becomes a vulnerability and basically you become out of compliant, then that's the straw that breaks the camel's back. So you need to move on and look for another SaaS provider that keeps you in compliance. Compliance is a big key.
Great. So I don't know if there's any other questions coming through right now. Just as a final word, two things, and I know they're not on the slide here, but if you do have questions, feel free to reach out to us. You have our email addresses. I've probably emailed you a few times in the past couple of days. And then secondly, if you are looking to begin your journey to the cloud, I'm not sure where you are in your stage, but we do have free assessments. So we can offer, the opportunity to look at what applications are ideal to move to the cloud first and how we can help you in your cloud journey. So if you're interested in that, feel free to drop one of us a line and I'll send you the details. And on that note, thank you, Alex, for your time this morning. And again, thank you, Ray. And I will be sharing the details of this recording with you all afterwards. Thank you.
Thanks, everybody.
Thank you.